This video will have to do with significant figures, or they're also known as, sometimes called significant digits, sometimes affectionately known as sig figs, and often when I'm grading student homework and I need to note that your number of significant figures isn't correct, I'll just write this, SF, to denote that it's significant figures that you're having difficulty with. So they might be called all of those things. An important idea about significant figures is that they deal with measured quantities, things that are measured somehow. Now, something significant about measured quantities is that they're never exact. We don't know exactly how long something happens to be, how far it is to some object. When we're measuring a time interval, there's imprecision involved with whatever clock we happen to have. So it's measured quantities that we have to worry about significant figures with. Other quantities we can say might happen to be exact. For instance, if you're concerned with the diameter of a circle, you can say the diameter is equal to 2 times the radius, and that 2 there happens to be exact. If you're interested in the circumference of a circle, you could say that the circumference is 2 times pi times the radius, and the 2 and the pi are considered exact. In this case, the thing that you'd have to worry about significant figures with would be the radius, because that's something that you'd have to measure, and so you could only have so much precision on something like that. We have to learn how to write numbers in a way that indicates the number of significant figures that they happen to have. So that's something that we'll have to learn to deal with. I'm going to write several numbers, all of which will have 3 significant figures. So my first one would be 455. That's a number that has 3 significant figures. I count from the leftmost non-zero digit to the rightmost non-zero digit. And 1, 2, 3. Got that. That one's pretty easy. Something else with 3 significant figures, though, is the number 402. That also has 3 significant figures. So that 0, when it's in between non-zero digits, is significant. Zeros end up being a little bit tricky when we're dealing with significant figures. We have to learn how to deal with them correctly. Here's another number that has 3 significant figures, 0.981. This one has 3 significant figures as well. That 0 out here is not considered significant. In fact, let me show you something else. If I have the number 0.000123, this also has 3 significant figures. These leading zeros on the left side are not considered significant. If this happened to be a unit that was, or a length that was measured in, for instance, kilometers, if this happens to be kilometers, we'll learn about unit conversion in another lecture, but I could also write this same number as 0.123 meters, and I could also write it as 123 millimeters. And all 3 of those represent the same number. All 3 of them have 3 significant figures. So those are some things to worry about. Now, an important distinction here. Decimal places are not the same as significant figures. You look at this number, it has 1, 2, 3, 4, 5, 6 decimal places, but it has only 3 significant figures. This number, the number of significant figures, happens to equal the number of decimal places, but that's not always the same. This number, you might say, because the decimal place would be after the 3 here, it has nothing after the decimal place, so I'd say it has no decimal places, but it has 3 significant figures. So don't confuse decimal places and significant figures. They're usually 2 different things. A number that I write, like for instance 4.52, that has 2 decimal places, or I've written it to 2 decimal places, but it has 3 significant figures. So that's something that we have to concern ourselves with. We can use many different types of notation for writing numbers, but one notation that's particularly helpful for it is scientific notation or exponential notation. If we write a number like 563,000, how many significant figures does that number have? Well, when you look at a number like this, it has at least 3. I know because from the leftmost non-zero digit to the rightmost non-zero digit, there are 3 digits there, so that would be 3 significant figures. I don't know if any of these zeros are significant, and it may be that someone just rounded the number to the nearest 1,000 here, and so there are only 3 significant digits, but I don't know any better than that. If I wrote the number in scientific notation to the correct number of significant digits, I could indicate with that notation how many significant figures there happen to be. And here's how I might do it. That number 5.63 times 10 to the 1, 2, 3, 4, 5. There's another lecture that you can watch on scientific notation. But that number could be written as 5.63 times 10 to the 5th. Now, the times 10 to the 5th doesn't tell me anything about the number of significant figures, but this number does. If I wrote that number this way, it would have 3 significant figures. If the number happened to have 4 significant figures, for instance, that 0 was also significant, 5.630 times 10 to the 5th, that has 4 significant figures. And so in this case, that 0 is significant. It's to the right of a non-zero digit after a decimal place. And those zeros are considered significant. If it had 5 significant figures, I could write it 5.6300 times 10 to the 5th. There, that number is written in a way that shows that it has 5 significant figures. If it has 6, 5.63000 times 10 to the 5th. That number has 6 significant figures. And so the way that a number is written can indicate extra significant figures if I tag those zeros onto the end. I'll write a series of numbers here, try to guess how many significant figures there are with each number. Let's look at the first number up here. This one, 1230, it has at least 3 or more significant figures, but I don't know if that last 0 is significant or not. It may be this was just rounded off to the nearest 10. So this one has at least 3, but I don't know about the fourth one there. If I wanted to write that number in a way that indicated that that 0 was significant, scientific notation would be the way to go. 1.230 times 10 to the 3rd would indicate that that one is significant. 1.568, writing the number that way, it's got 4 significant figures. 632.991, that's got 6. That's how many digits there are from the leftmost to the rightmost non-zero digit. So, and that would include 0 digits in between there. So this one has 6 significant figures. 456.5, that has 4 significant figures. 0.00001. These leading zeros are not significant. This one only has 1 significant figure. It's that 1 right there. This next number, 0.0000565, The leading zeros are not significant. The 5, the 6, and the 5 are. So this has 3 significant figures. I want to reiterate a little bit the part of zeros in between numbers. If I have a number that looks like this, 1, 0, 0, 0, 5, these zeros between non-zero digits are significant. So this would have 1, 2, 3, 4, 5 significant figures. If I had a number that was written as 0.007006009, okay, these leading zeros are not significant. Here's a non-zero digit, more zeros between non-zero digits, so all of these zeros are considered significant. And if I tagged a couple on the end and the number was written this way, when they're tagged on the end that way, after to the right of a decimal point, they're considered significant. So here I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures there. So that's the way that I would write that thing. This is an introduction to writing numbers with the correct number of significant figures and then interpreting those. In a future video, I'll show you how to do calculations with those and see how they work out there.